Hi, this is Team SC-Trailblazers here, and we have the Einstein. We present you Einstein, which is an AI platform aimed at increasing organic connectivity and engagement between professors and students by generating context-aware questions and answers from live lecture transcripts. So let's see how it works. We have implemented it using NLTK and transformers on the back end using machine learning. But let me give you a quick walkthrough. So this is the landing page. We're assuming we're logging in as a professor. We're creating a new quiz called a history quiz. Let's see how our students fare. If our transcript for the lecture was something like this, so as you can see right now, what the app is doing is it's connecting to our API, which sends a post request uh, to our ML model, which generates the questions for question and answers for these quiz. Uh, Now, what the student will do is kind of log in and see this quiz and attempt it, and then they would see these questions in. Now they can enter answers like, okay, when did Einstein move to Switzerland? Let's say 1905. When did Einstein acquire Swiss citizenship? I don't know, 1920 maybe. Who awarded Einstein a PhD in 1905? Somebody. Who came to power while Einstein was visiting the United States in 1933? I think it was Hitler. When did Einstein become an American citizen? I don't know, 1990. So submit answers, and now the student will log out, and this is just a prototype, of course. The professor would log in, and then they would have the option to evaluate. They would see the student's answers here. So as you can see, the actual answer is visible here. And these things are generated automatically with our AI. So professor can assign a score and then submit. So that's all of the functionality that we have. But what we really want you to know was what went behind this application in the back end. So I would start with the GCP Google Cloud Platform. We have a high performance VM instance here on the GCP deployed. So as you can see, it has 4 virtual CPUs and then 15 GB of memory and then 1 GPU, which helped us a lot with our training. We have defined custom traffic rules and deployed a Docker image to make it map properly. Yep, all that good stuff. And then we also have monitoring available. So as you go here, we can actually go to our monitoring dashboard, which will show up as the metrics. So we can see our VM instance, we can see stats like our CPU usage. As you can see, the CPU usage went up because I just showed you ML queries. So yeah, of course, our app engine had to work hard there. Um, let's explore it a little bit more. So this is if you SSH, uh, into our VM, and then coming to our Google Cloud Firestore. So this is our data store, which is actually kind of storing all those responses which it got from the API. So the history quiz is stored here, and these are just some placeholder quizzes that we created earlier. If I also want to show you the actual API that was created. So if we go to quiz main and actually, yep. So this is our post request to our API. As you can see, we have the VM exposed at a IP here and to the endpoint quiz, which takes in the body as a JSON input of our input text, which parses the corpus, which is basically a transcript. And so the future development on this app would be to integrate live videos and extract video and audio from them, and integrate a speech to text platform to actually make it more dynamic. That was us, team SC Trailblazers, with the platform Einstein. Thank you so much.